Early. Let me know when you're ready. Okay.
That's it, you're on.
I'm on. All right, let's go. So I'd first like to ask you to take a look at the TV screen and move your eyes around, look around a little bit and ask yourself, are the colors moving, shifting just a little bit? Maybe? Let's try a different one. Look at this. Now if you're looking at it and your eyes look around, does it look like the ball's kind of moving just a little bit? Kind of weird, huh? I got one more for you. Check this one out. Look at the blocks, where the letter A and the letter B is. Are they the same color? Don't really look like it. What if I told you they're the exact same RGB code value of 120, 120, 120? I can prove it to you again. I'm going to draw two lines going through the other one of the same color, and it looks like the A and B are exactly the same color. So I'm not going to get into why this is, but this is just to say that, you know, the ways that our eyes and rods and cones interpret colors is very complicated. And so color management is what I'm going to be here talking with you about better pixels and better colors. So we're going to talk about color management, specifically HDR in live productions. And my name's Tim Walker. I'm with AJA, proud to be here speaking with you from VETV today. I'm a product manager at AJA Video Systems. I currently manage a number of products. All of our color products are HDR technologies, frame syncs, routers, scaling and scan converters, and some of our open gear products. So we're talking about HDR and live workflows. What are our goals? What are we trying to accomplish? We're trying to produce high quality HDR content. We're trying to capture video correctly. We're trying to maintain a consistent look across all of our sources, devices. Potentially we might need a round trip, which is going from SDR to HDR and back to SDR. And most of all, be efficient. This is live television. So what are some of the challenges you're going to come across? Well, you're going to come across different sources that have different native color sciences or color spaces. You have to consider your different deliverables. You might have SDR, HLG, PQ. You might have 720p, different resolutions, 1080i, 1080p, all the way up to UHD and 4K. The deliverables might be over the top, over the air, mobile, direct, lots of different things. You got to be careful with the RGB signal ranges. There's SMPTE full, SMPTE narrow, and there's also scene referred and display referred. And then you got to do camera shading. And then the biggest challenge of all, again, is coming back to time. There's also other challenges with ranges and gamuts. We're talking about different dynamic ranges and color gamuts now. So with native cameras, you'll have different camera log outputs. You might have Sony S-Log3, Panasonic V-Log, Canon Log3, the latest RE Log C4, even Red Log 3G10. And then you have different displays that you need to be considerate of, which are SDR BT709, HLG BT2020, and PQ BT2020, or even P3. And those aren't just displays, but they're display formats. Then you got other color spaces like ACES, which is the Academy of Color Encoding Systems. So lots of things to be considerate of when considering color managed workflows. So now you've got all those dynamic ranges and gamuts. How do you convert between the two? How do you make things work well together? So you have different approaches for this. You can use 3D LUTs to convert between different color spaces, ranges, and gamuts. So you want to have a 33-point 3D LUT with tetrahedral interpolation in the processor, and that's kind of a good standard for broadcast. The 3D LUTs themselves can include some creative elements if you want them to, rather than just be a straight SDR to HDR conversion. You can use 1D LUTs, which have 12 bits generally in some of the products for high precision, and they can help you make better use of the code values that are in the 3D LUT themselves. There's 3x3 matrices, which are mathematical formulas that are used for color correction or color space conversion, even maybe white balancing. So there's lots of different things, and it's the combination of all these things that can make a really good transform. The last approach, is an algorithmic approach. Yeah. So the last approach would be an algorithmic approach to color conversion. And these use complex sets of equations and account for multiple factors, and they might even have the ability to customize a look or a correction, if you will. So this is where we introduced the idea of a color managed workflow. And this is something we hadn't really had a lot to think about in the past in live production. But now that we've got this mixed situation where you might have camera log inputs, SDR inputs, and HDR inputs, you need to convert those into a single dynamic range and color space, which then can be distributed or converted to the different output deliverables. But what is a color managed workflow? It's an understanding of color spaces, conversion techniques to ensure colors represented accurately and consistently from glass to glass, camera to the home, no matter the input or the output. That's the gist behind what a color managed workflow is. So now let's bring this into how people first started doing HDR productions in live production. There were side-by-side productions using a complete SDR signal chain and workflow with SDR inputs and SDR outputs and separate HDR sources, which had to be converted into SDR, but then also a complete separate HDR production switcher was used for a total of two full productions. So this was not economical, cost a lot in switchers, manpower, signals, it was just not very economical. What we've ended up kind of standardizing on in live production now is what we call a single master or single stream HDR workflow. And so what this does is this takes all of your SDR inputs, converts them into HDR, because when we're doing an HDR production, every source that lands on the production switcher needs to be in the same dynamic range and gamut color space. So we're going to convert signals to match our production format. In this case, it says HDR. Most common today in live production is HLG BT 2020. So we'll convert SDR to HDR, we'll process everything in HDR, and then we'll get our deliverables converted on the output. So you might record in HLG, but you might have SDR deliverables for the wider viewing audience, and we'll do those conversions on the output. So I know this looks like a lot of conversions, and it is. Well, that's the way it works today when you've got a blended SDR and HDR sources and destinations in your workflow. So I'm from AJA, so this brings me to the big what if. So what if you had a product or one tool that could help you set up faster, convert dynamic range and gamuts with high precision, access both LUT and algorithmic transform options based on what your conversion needs are, that could help you maintain consistent looks across various different source devices, such as the cameras and the replay machine, for instance. Produce high quality results, and also allow you to share some of those decisions that you've made so they can easily be replicated again and again, so you're not having to reset up everything. And all this could help you, reduce errors during production. So what if? What if you had a tool such as AJA's new color box? This is something that we've introduced a year and a half ago, and we're still innovating and bringing new features and functionality into the product. But this is an inline HDR and SDR transform device, and camera log, by the way. So it has LUTs and algorithmic transforms built in it. Let's go through it a little bit. It has 6 color processing pipelines that support log, SDR, and HDR conversions. It has a beautiful web UI that has a video preview so you can see what's going on. It has various hardware control options. So just looking at the hardware a little bit, you'll see it has 12G SDI inputs and outputs that support up to 4K 60p. 12-bit RGB is also supported, giving you some of the highest color fidelity, and we support that up to 4K 30p. It also has an HDMI 2.0 output, which supports 4K and HDR for local monitoring. Talking about the size of this thing, we want to make sure it's nice and compact, so we can fit 4 of these in one rack unit, giving you 4 HDR color conversions and 1 RU in 4K, which is nice density. I'm not going to go through this in great detail, but this is one of the first this is the AJA color processing pipeline. This is the look at the user interface where it shows the beautiful image preview that I described earlier. This pipeline is built around a 33-point 3D LUT in the middle, which is here in orange when it's turned on and in dynamic mode. but it also has 4 additional 1D LUTs and 2 3x3 matrices around that 33.3D LUT. This helps with many different types of conversions that I just spoke about earlier. It has the ability to support user LUTs, so you can load in different LUTs that you may have into this pipeline and use those. It has dynamic LUTs for third-party control. You can even change some of the nodes to be RGB color correctors or proc amps, because that's what we're familiar with in the live production color correction vernacular. And each one of the 7 nodes of processing is individually configurable, where you can toggle them on or off. We have another processing pipeline using different color science. So we have a color processing pipeline from ColorFront. This uses the ColorFront engine color science, which is based on the human visual system. So it allows you to do transforms that are going to be much more appealing to the eye and how the brain interprets colors. It maintains perceptual integrity through the transforms. It also has a special round trip setting to help you get that SDR to HDR and back to SDR just right. We also have the NBC Universal LUTs. These are also LUTs that are built into the color box and freely available. They're developed by NBC Universal in conjunction with Chromorama, who also developed Orion Convert, which I'll speak about in a minute. This pipeline has SDR, HLG, and PQ transforms in it, as well as display and scene light conversions as well. Has that proc amp and color corrector for color correcting the source before it goes into the transform. We've also got Orion Convert. So this was a new pipeline that AJ is the only one that can offer this. And what's different about this is a couple things. First off, it's actually the tool that was used with NBC to create their LUTs. And that's great. So those use 33.3D LUTs. That algorithm, when it's implemented in Colorbox, we did it using floating math. And what does floating math mean? It means we get away from using the 33.3D LUT, which can have some interpolation errors, which means we're not exactly sure where that color lands when we go through the transform. But doing it in floating point math, we're able to precisely calculate each pixel value, which gives you a great resultant transform. And with the kindness of NBC, we're able to load in the NBC LUT presets into this, so you can exactly replicate the NBCU transforms, but with a higher precision than a 33.3D LUT. It has some other great tools in it that we could get into if we had more time. But the next pipeline that we have is the BBC HLG LUTs. These are some of the first LUTs that came onto market to help promote the HLG live production workflow. There's a wide range of LUTs that are available in this pipeline. It also has a proc amp and color corrector. And then our newest and latest pipeline that we've added is the ACES pipeline. So this is our 6th pipeline. It's brand new. It makes the ColorBox the first device to support AMF files. And AMF is an ACES metadata file, which is basically a recipe of a bunch of different transforms to do a conversion. And we can import an AMF file and simply load it into our library, turn it on, and we're processing ACES conversions. This was built using OpenColor.io underneath the hood. So you're like, okay, Tim, like that's great, it does all that stuff, but what's the latency going through the box? Well, this is a really fast processor. So for live production, it's really important. Live only happens once, and it needs to be low latency. So we were able to do all this processing in less than half of a video line. And why half of a video line? Because the downstream production switcher that's going to be receiving this signal has an auto timer on the input that is generally plus or minus half a line. So we wanted to make sure we were in that timing window of the downstream production switcher, ensuring we weren't adding any additional delay. So it's really fast. So some of the new features that we added, new for the show, is within the ColorBox version 2.1 feature set. We added a new 4K down conversion, a 4K 2K crop on the HDMI output. We added the new ACES pipeline that I spoke about earlier. A new thing to support RE Alexa 35 workflows, which will be soon come into live production. And we updated the ColorFront engine as well as the BBC HLG LUTs. So it's a powerful update for this product for the show. I mentioned at the beginning that we had some hardware control options because not everybody likes controlling, color correcting from a UI. So through the ColorBox's rich REST API, we've worked with several control panel manufacturers, including Scarhoy and CyanView, where they can control the ColorBox natively through our API. So simply from an Ethernet connection, they're controlling our box directly and have access to all the parameters that are inside the ColorBox, giving your camera shaders tools that they're familiar with in a way that they're familiar in controlling color correctors. But look at this, not only do they control the ColorBox from AJA, but they also control AJA's FS-HDR product. So what is the FS-HDR? I'm not going to go through it in great detail, but the FS-HDR has been a workhorse in the early adopters of HDR live production. This has got a lot of the same color conversion options that I spoke about earlier with ColorBox, but at its heart, it's also a frame sync. So it's a frame synchronizer, up-down cross converter, audio router, video processing, HDR mapper. It's a powerful box. It's a workhorse. There's a bunch of audio processing as well. So it was, it also has the ColorFront engine in it that I spoke about with the ColorBox, the same one. It has the BBC HLG LUTs, the MBCU LUTs, and also user LUTs. So this is just a little look at some FS HDRs in action. This was a trip that I went on to Mountain Mobile in Colorado, where they had several racks of FS HDRs supporting their single master HDR workflows. So just coming back to this, everywhere where you see one of those gray boxes would be a great spot to put an AJA ColorBox or an FS HDR. If you have questions about which one works best in which situation, feel free to reach out to anybody at AJA and we'd be happy to help you. And I'd like to thank VETV for giving us this opportunity to do this presentation, and thank you very much. Nope. Maybe you can cut that part out. Right then. All right, it's good. How do we do?
Anybody?
Got any questions?
You did great.
Rob, you got any questions? I saw you join there at the end, huh? You're like, you already know all this stuff. Yeah.
Tim, thank you so much. We will be editing this, of course.
Yes.
You're going to give me your material.